Today is September 9th, 2019, and we are coming back to Eureka Math to do Module 1, Lesson 11. You'll notice we skipped some lessons, okay? So in your workbook, there will be some lessons, like 7, 8, 9, or whichever, 10, whatever, that we didn't do. We're going to skip them for now, okay? Don't worry about it. You don't need to take them out, nothing, just leave it. Okay, but we're skipping to lesson 11 today. And today what we're going to do is we're going to use what we know about place value to help us add multi-digits, that means more than one digit, numbers, using the standard algorithm. Okay? When we round, we can find out, if we round to the thousands, the sum is 37,000 calories. When we round to the nearest 10,000, it's 30,000 calories. Which is more accurate, 37,000 or 30,000? Why is 37,000 more accurate? Because it's closer to the actual amount, huh? When we round to a smaller place value, it's going to be more accurate than we round to a greater. On your test last week, there was a question that asked this, didn't it? A lot of us put like, well, I think this one, because it's closer to 500, it's halfway. Does that have anything to do with it? No. Your most accurate estimate will be the estimate that rounds to a smaller place value unit. When we rounded to the thousands here, that's smaller than the 10,000s. So this one is more accurate. Does that make sense? Because it's closer, it's more accurate because it's closer to the actual amount. Today, start by copying this question down. 3,134 plus 2,493. The question asks us to use discs or circles on the place value chart to help us add. So that's what we're going to do. Let's take a look at this first one first. The first addend. Different parts of an addition equation, by the way, are called addends. Okay, so it says 3,134. How can we represent this on the place value chart? Well, I could draw 3 discs in the thousands place, 1 disc in the hundreds place because there's 100, 3 discs in the tens place because there's 3 tens, and of course 4 discs in the ones place. Yes? Now to that we have to add this amount. We have to add 2 thousands, 4 hundreds, 9 tens, and 3 ones. We can go ahead and draw those discs, but I want to show you something that I was telling the 5th graders. What I like to do when I'm drawing this is I like to make 5 discs go across before I start the next line. Let me show you what I mean. 2 thousands. Oh, that makes exactly 5. 4 hundreds. 1, 2, 3, 4. That makes 5. Let me show you what I mean in the tens. Do you see how I have 3 there so far? How many more tens do I have to add? 9, right? So I'm going to go 1, 2, and I'm going to start the next row. 3, 4, 5, 6, 7, 8, 9. Do you guys see how I made it so there were 5 in each row? Why do you think I do that? That makes it really easy now to see when I have a bundle of 10. Do you guys see that? And we know, based on what we know in the place value charts, that bundles of 10 are important. We're going to get back to that in just a second. First, I want to finish the ones. I have 3 ones, so same thing. I already have 4, so I'm going to do 1, 2, 3. Okay, again, I like to draw it in bundles of 5 because that helps me see bundles, or rows of 5 because it helps me see bundles of 10. Because then I can circle the 10 tens, and I know those 10 tens become 1, what? 1 what? 100. This is called regrouping. I can bundle up 10 of one place value unit and regroup them to become one of the next. And when you regroup, I want you to circle them all. Cross it out to show that I am regrouping it. It's no longer 10 tens. Instead, I'm considering it to be 100. Okay? Now let's see what we have all together. How many thousands do I have? 1, 2, 3, 4, 5. Okay? How many hundreds do I have? Everyone? 6. Do you guys see how it's 6? Be careful. How many tens do I have now that I've regrouped? 2. And how many ones do I have? 7. Drawing the discs in rows of 5 also helps you see how many numbers you have all together. Because it's easy. You know one row is 5. Okay? Very good. So, what's 3,134 plus 2,493? The answer is 5,627. This is an example of how to use discs on the place value chart to add. And now, the directions tell us to use numbers on the place value chart. So let me show you how that works. We have 3,134. And I have 2,493. Now instead of discs, I have numbers on the place value chart. Okay, let's see how we can use what we know about addition, and we can imagine those place value discs in our head as we add. If I have 4 ones, and I want to add 3 more ones, how many ones do I have altogether? Everyone? 7 ones, good. If I had 3 tens and I want to add 9 more, how many tens do I have altogether? If I have 3 plus 9, what do I have, everyone?
12.
12. Good. So I have 12 tens. But using what we know about place value, do we write 12 tens? No, because we know that 10 of those tens are going to be regrouped, right? So here's how we write it using the standard algorithm. We record 2 of them, and we know that we're going to regroup 10 of them to become 100. Yes? Now I have 100. I'm going to add 1 more and then 4 more. How many hundreds do I have? 6. And get in the habit, once we use that regrouped one, cross it out. Okay, then I have 3 thousands, and I want to add 2 more thousands. How many thousands do I have altogether? 5. So the answer is 5,627. Same answer we got before with the discs. I want you to talk with your table group. What is the same about using numbers compared to using discs? Go. It's the same problem again, but this time it says use a tape diagram. This is something new for 4th grade, okay? A tape diagram is a way to draw a picture that represents the addition. When you have a piece of tape, it's just a rectangle. Do you guys agree? When I rip you a piece of tape, it's a rectangle. A tape diagram is a picture that we're going to use. It's a name that means a math picture, and we're going to use this over and over again. Let me show you how to draw a tape diagram. It shows that you have, this is a piece of tape, isn't it? Do you guys agree?
Yeah.
And this piece of tape is 3,134. You're going to label it. You don't need to draw an arrow, but you need to show that that piece of tape is worth 3,124. Now I'm going to add on to that piece of tape to make it even longer because it says I'm adding. Do you see that? And how much am I adding on to that? 2,493. And so all together, we're using brackets, that's what we're trying to find out. We're trying to find out if I have a piece of tape that's 3,134 and I add to it 2,493, how much do I have altogether? A tape diagram is simply rectangles with labels. Okay, do you guys see that? Draw the brackets and use the question mark to show that that's what we're finding. Now, because we've done this problem twice already, we know that the question mark is worth 5,000, what? 5,000? Thank you. Okay, but this is, I just want to show you that when it says draw a tape diagram, this is what it means. Does that make sense? We have one piece of tape, we're adding on another piece of tape, and we're trying to find out how much it is altogether. If I just drew this, would that be a tape diagram? No, because there's no values. Tape diagrams always need labels. Okay? Good. The standard algorithm is doing addition where you write it vertically where the ones are on top of the ones. The tens are on top of the tens. Everything is lined up. So you can imagine yourself a place value chart, okay? And place value charts just help you line up the place values. So let's use the standard algorithm to solve this. We have 207,426. We want to add up 128,744. And we write the addition sign on the left here, and we draw a line like that. It should be a review to you guys. Every time before you start adding, I want you to get in the habit of making sure that your place values are lined up. What I mean by that is, are the ones on top of the ones? Are they?
Yes.
Okay. Are the tens on top of the tens?
Yes.
Are the hundreds on top of the hundreds?
Yes.
I want you to check this because it's very easy, especially if you have messy handwriting, to kind of get off centered, right? And then you won't be adding correctly. Okay, now that we're set up, let's go ahead and add. If I have 6 ones and I want to add 4 more ones, how many ones do I have altogether? Everyone?
10.
10 ones. But I know 10 ones can become 1.
10.
So I'm going to regroup all 10 of them. So I'm going to have 0 left. And I'm going to regroup them to become 110. Very good. Now I have 110. I'm going to add 2 more 10s. And I'm going to add 4 more 10s. So how many 10s do I have altogether?
7.
7. Good. No regrouping necessary. Now I have 4 hundreds, and I'm going to add 7 more hundreds. How many hundreds do I have altogether, everyone? 11. But 10 of those are going to become 1,000. So if I have 11, I regroup 10 of them. How many do I have left? 1. Good. So record that one. Okay, I have 1,000. I'm going to add 7,000 and then another 8,000. How many thousands do I have altogether, everyone?
16.
But as we know, 10 of them will become 1 what?
10,000.
10,000. You got it. Okay, I have 10,000, and I want to add 2 more. How many 10,000s do I have? 3 10,000s. Very good. Okay, I have 200,000s and I want to add one more 100,000. What do I have altogether? 300,000s. Okay, so our answer is 336, comma 170. But how do I say that using word form? First tell me, how many periods do I have altogether? 2. Okay, let's name it period by period. In the first period, what number do you see? 336, what is that?
336,000.
Very good. Then I have 170, and that's it. So the whole number altogether is 336,170. Very nice.